Hi everyone, welcome to My Max Academy. In this video, we will continue with chapter 1, which is real numbers from 10th standard CBSE mathematics. We'll continue from exercise 1.1 in page number 7. Exercise 1.1 from page number 7 in your textbook. And so we will, in the last video we did till the first problem. We'll start with the second problem. Second problem is, it says show that any odd positive integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. So what we have to prove? We have to prove that, what we have to prove? To prove that any odd positive integer is of the form 6q plus 1 or 6q plus 5, sorry, 6q plus 1, 6q plus 3 or 6q plus 5. We have to prove that any odd positive integer, it is in this form. It is in any one of the three forms, which means, for example, if I have an odd number, suppose 11 can be written as what? 6 into 1 plus 5. So 6 into something plus 5, which is in this form, 6q. This is like 6q, 6 into q plus 5, right? 11 can be written as like any number. Even if I take the number 1 can be written as 6 into 0 plus 1. Like this is 6q plus 1 form. Right? Similarly, if I take any number, if I take 21 can be written as 6 into 3 plus 3, which means 6q plus 3. So that's what it says. We have to prove this. Then I told you for such problems, right? The solution is, we will take first, let a be any positive integer. A be any positive integer. We have to take as, let a be any positive integer. That I am taking a. I am not giving any specific value for a, right? So let a be any positive integer, right? And but what we have to prove? We have to prove any odd positive integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5. This is similar to your example 3 in your textbook, page number 6, similar to that problem. So then what we'll assume, we'll take let b equal to, always you will mostly take your b as the 6, right? Whatever that is 6, whatever is coming before q, most of the problems will take that as 6. Some problems it will change, that I'll tell you, but mostly it will be 6. Now by Euclid's division, we are going to apply Euclid's division lemma. What is division lemma? That is a equal to bq plus r, where 0 less than or equal to r less than b. This is your Euclid's division lemma. We are going to apply this for these two numbers. What are the two numbers here? A is one number, b is 6. B we know the value is 6, but a is any general number, any number. So then I'll put a as a. In the place of b, I will put 6. This is q plus r. And 0 less than or equal to r less than 6. You see, this is b, this is 6. B is 6 here. Now, which means a equal to 6q plus r, where your r can take the values 0, 1, 2, 3, 4 and 5. So what is the meaning of this? 0 less than or equal to r less than 6 means your r is between 0 and 6, but it includes 0 because it is less than or equal to, but it doesn't include 6. So you have to start from 0 and write the integers 0, 1, 2, 3, 4, 5 till 5. You cannot write 6. Now we need to have different cases. We need to have 6 cases, right? So first case, for each value of r, we need to have one case. So case 1 is when r equal to 0. If you put r equal to 0 here, what happens to this? So my a is equal to bq plus r. So my a will become, 6q plus r. My a is 6q plus r. So 6q, this is 6, not b, 6q plus r. So if you put r equal to 0, I'll get 6q plus 0, which means a is equal to 6q. Then I need to check whether a is an odd positive integer or even positive integer, because a is any positive integer. Now, to check whether it is an even or odd, I should see whether I can write this as 2 into something. Any even number, will be of the form 2m, where m is some integer. 4 can be written as 2 into 2, 8 can be written as 2 into 4, and 24 can be written as 2 into 12. So any even number can be written as 2 into some number, right? So which means I can write this as 2 into 3q. I can write this as 2 into 3q. So then that is equal to 2 into m, where m is equal to 3q. Instead of 3q, I am calling that as some m. Now it is in which form? A is equal to 2m form. When a is 2 into something, then it is an even number. So therefore, a is an even positive integer. A is an even positive integer. Which case, when a is in the form of 6q. In this form, it becomes like this. Don't worry about this form. This form says whether it is even or odd. We are getting in this form to show that it is even. But actually, what is a equal to 6q? When you substitute r, what a is? So when a is 6q, a is an even positive integer. But we are worried about odd positive integer. So we'll go one case by case. Case 2. Second case. Second case is when r equal to 1. What is my a? A equal to 6q plus r. So a becomes 6q plus 1. So we need to substitute the value of r in this one. For every r we have to substitute. So now this is like 6q plus 1. Now a is equal to 6q can be written as 2 into 3q plus 1. 2 into 3q, 6q. Now then a is equal to 2 into m plus 1, where m equal to 3q. Where m equal to 3q, which means where m equal to 3q, right? Which means a I am writing it as 2m plus 1. So if any number it is in the form of 2m plus 1, 2m is even, and to that if I add plus 1, it becomes odd. So this number 2m plus 1 is always odd. So this makes your a as, therefore a is an odd positive integer. Odd positive integer. So which means in the case where a equal to 6q plus 1, a becomes odd positive integer. Which means when I put r equal to 1, my 6q plus r becomes 6q plus 1. In this case, we have showed that a is an odd positive integer, which means if a is odd positive integer, when a is 6q plus 1. Right? Now let's take another case. We'll take case 3. Case 3 is when r equal to 2. What is my a? A is 6q plus r. So a becomes 6q plus r. R is 2. So that a equal to, either I have to write a as 2 into m or 2 into m plus 1. 2 into m plus 1. Right? If I write it as 2m, it is even. If I write it as 2m plus 1, it is odd. If I write it in this term, it is even. So now, is there a way that I can convert 6q plus 2 as 2 into something? I can take 2 common. This will become 3q plus 1. Then a becomes 2 into, instead of this entire 3q plus 1, I will put m, where m equal to 3q plus 1. Now a takes the form of 2m now. When a is 2 into m, then it is even. Therefore, a is an even positive integer in this case. So which means when a is 6q plus 2, a becomes even positive integer. Now case 4. When r equal to 3, and substitute r equal to 3. So when r equal to 3, my a is equal to 6q plus r. My a becomes 6q plus 3. Now a equal to, now here I should either write this as 2 into something, or I should write it as 2 into something plus 1. Either I should write it in this form or this form. But here I cannot take 2 common here from these two. And there is no 1 also here. It is 3, but we need 1. Or this should be an even number. If this is an even number, then I could have taken 2 common from the whole. But I can't take 2 common. So which means what I will do? I will split this 3 as 6q plus 3. I will write as 2 plus 1. Either I should be able to take 2 common from both, or I should get a 1 then 2 I cannot take common. The moment if you cannot take 2 common, only if you take 2 common you can show this as even. If you cannot take 2 common, then break your 3 to 2 plus 1. Now from these two I will take 2 common, then I will get 3q plus 1. This is plus 1, right? A becomes 3q plus 1 plus 1. Now A becomes 2 into, instead of 3q plus 1 I will put m, then this is plus 1. So this plus 1 is not part of 2, but this plus 1 is with the 2, because 2 into 3q you will get 6q, 2 into 1 you will get 2, 2m plus 1, where m equal to 3q plus 1. Now here also what happens? A is of the form 2m plus 1. If it is in this form, like this form, therefore A, in this case, therefore A is an odd positive integer. A is an odd positive integer when it is in the form of 2m plus 1. Now let's take the next case. Case 4. Case 4. Case 4 is when r equal to 4, because we are substituted till 3, we have to go to the fourth one. When r equal to 4, my A is 6q plus r, my A becomes 6q plus 4. I have to substitute in the place of r 4. Then I have to see whether both are even. If both are even, then I can take 2 common. 6 is even number, 4 is even number. I can take 2 common. Then it becomes 3q plus 2. Here just try to take whether we can take only 2 common. Right? So now A equal to 2 into, instead of 3q plus 2, I'll put some m, where m equal to 3q plus 2. The 3q plus 2 I'm calling it as a m. Then what happens? Then A is in the form of 2 into m. Therefore A is an even positive number. A is an even positive number. Now let's go to case 5. Sorry. Case 4, this is case 5. I'm sorry. This is case 5. Here we have done case 4. Case 3, case 2, case 1. Case 1, case 2, case 3, case 4, case 5, case 6. Case 6, which is the last case, where we'll put r is equal to 5. Now when r is equal to 5, so what happens? My A is 6q plus r. Now I need to substitute r is equal to 5. So A becomes 6q plus 5. A becomes 6q plus 5. So A becomes 6q plus, okay, here before I write this, we need to check whether you can take 2 common. Can I take 2 common from both? No, because this is odd number. I can't take 2 common. The moment you cannot take 2 common, then you have to break your 5 as 4 plus 1. So my A becomes, right? My A becomes 6q plus 4 plus 1. The 5 I am writing it as 4 plus 1. 5 is written as 4 plus 1. How we wrote here 3 as 2 plus 1. Now A equal to, now from these two I can take 2 common. Then I'll get 3q plus 2. Then this is plus 1. So now this is 3 into 2 into 3q is 6q, 2 into 2 is 4 plus 1. Now this is like 2 into m plus 1. This is 3q plus 2, where m is 3q plus 2. Now A takes the form of 2 into m plus 1. So 2 into m means even, plus 1 means it becomes odd. Therefore A is an odd positive integer. Now if we observe, right, where and all A is getting odd, here, here, here. Case 2, case 4, case 6 it is getting odd. Case 1, case 3, case 5, A is becoming even positive integer. So therefore whenever A takes these forms, 6q plus 1 or 6q plus 3 or 6q plus 5, A becomes an odd positive integer. So therefore we have proved that. So therefore we can say, so therefore I am writing the conclusion here. I could have used that. So therefore any odd positive integer is in the form of 6q plus 1 or 6q plus 3 or 6q plus 5 for some integer q, where q is an integer. Q is any integer. For some integer q. Clear? So this is the proof for the second problem in exercise 1.1 in your textbook. Clear? So it's a easy thing. You have to always take a as any positive integer, then b will be whichever form we need to prove. 6q, that 6 will be b. Then you have to write equalization lemma, take the possible values of r, keep substituting them and check where a is becoming even and where becoming odd. A is becoming odd in whenever a is 6q plus 1, and if it is 6q plus 3 also odd, then 6q plus 5 also it is odd. So that is why we are writing these three. Clear? Okay, now let's go to the next problem in your textbook, which is problem number 3. Problem number 3 in the textbook. So it says that an army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Which means there is an army contingent of 616 members, right? Army contingent of 616 members are there, right? Then we have army band. Army band, it has army band of 32 members. So they have to march in a parade. Have you seen the parade? Right? So group of people with the band, they will go in the front with, with the drums, and, you will see a set of people marching behind the set of people. So set of people with the band will be in the front and others will be at the back. Then they will be marching, right? You might have seen this in the Republic Day parade and all that, right? So here what they are asking is, so the question is 616 army contingent member of 616 and army band people of 32 members, they have to march, right, in such a way that we have maximum number of columns. We have maximum number of columns, and we should have same number of, the group are to match in the same number of columns. So which means we should have same number of people in each column. Suppose if we have the band people are like this, suppose they are marching towards like this, okay? So it will be like this. Suppose it is band, then then this B, I'm denoting this army band people. Army contingent I will denote by the symbol C, like this. So they will march like this. They will go in this direction. They will march, right? So here it is only 1, 2, 3, 4 only there, but there are 32 people. So which means I should have some more B's, like that. So here also many C's will come. So if you add all the B's, you should get 32. If you add all the C's, you should get 616. And this is the column. This is one column. They will march. This is another column. This is another column. This is another column. I just wrote some example for you to explain how they are marching. So this C means these people. Contingent people are here and band people are here. I am putting the simple band. So there will be many bands. So if you count all the B's, you should get 32. You should get 32. Now we should find what is the maximum number of columns possible. What is the maximum number of columns possible in which they can march? And these two groups should march in the same number of columns. Right? You cannot have some BB here and nothing, nobody is here. That is not possible. Right? Which means we need to see what is the maximum number. Right? We need to find the maximum number of columns. Right? Which means we need to find what is the maximum number, or what is the maximum number of columns army band can march, and what is the maximum number of columns this army contingent can march maximum number of columns. Here 1, 2, 3, 4. Here 1, 2, 3, 4. Band is marching in 4 columns. Contingent people are also, army contingent is also marching in 4 columns. Right? We need to find the maximum people that can be in a particular column, and the same number of columns even the band people should be set, which means we need a same number that can have maximum number of people for both, which means we need to find the maximum number that divides both, which means we need to find the HCF. We need to find the HCF between two numbers. Clear? So I will write here. So solution is SOLN solution. Okay, solution or the answer or proof, whatever. Right. So now we will say since the two groups are to march in the same number of columns, then also we need to have maximum number of columns. We need to have maximum number of columns. Which means we need to find the HCF between 616 and 32. So we need to find the maximum number that can divide 616 people into different columns, and the maximum number of people that can be in each column for these 32 members, or the maximum number which can divide these 32 people into different columns. You need to find the maximum number that will divide 616 members into different columns, and maximum number that will divide 32 people into different columns, and both of them should have same number of columns, which means it should be common, which means you should find the highest common factor. So now we will find the HCF using Euclid's division algorithm, right? So now to find the HCF, what is our step 1 in that algorithm? Step 1 is we will take A as the bigger number 616 and B will be 32. So we are going to apply Euclid's division algorithm to find the HCF between the two number which I had explained in the previous class videos of this chapter. Fine. So A is 616 and B is 32. So which means what is our, by Euclid's division lemma, what we have? We can write this as A is equal to BQ plus R. A can be written as BQ plus R, which means 616, I should write it as 32 into something plus R. That Q is something. So which means we should divide 616 with 32. Right? And then we should find the quotient and remainder. So how many times it goes? 30 ones are 32. Right? The remainder is 9, 2. Then I bring this 6 down. Now 296 will go how many times? Does it go? What is the 32 into 9? 18, carry 1, 27, 28, 288. So it goes 9 times. So 288. Right? So then this becomes, the remainder is 8. And that's it. 8 is the remainder. So which means this can be written as 32 into 19 plus 8. Right? Now what is the remainder? Remainder is 8. Remainder is not 0. If the remainder is 0, then b equal to 32 will become the HCF, highest common factor, but it is not 0. So we need to continue to step 2. So step 2 is what? We should take a as the b, which is 32, the b of the previous step, and the new b will become the radius, remainder r. The new r, which is the remainder. So the new b will be here the remainder of this. This is the remainder. This is r, this is q, this is q, this is b, this is a. This is a, this is q, this is r, this is a, this is b. Right, now again apply, right, by I am writing in short Euclid's division lemma, EDL, Euclid's division lemma. Now I have to write this as a can be written as 32, can be written as 8 into 4 plus 0 in this form, bq plus r, which means you need to divide. You need to divide 32 with 8, you get 4 times 32, remainder is 0. So 32 can be written as 8 into 4 plus 0. The moment you get 0, then we got the final answer. So which means this will be my HCF. Therefore, HCF of 616, 32 is 8. So therefore, the army contingent and army band should march in 8 columns. The maximum column that is possible is 8, because there is a maximum number that divides both these two numbers. There is a maximum number that divides both these two numbers. Clear? So that is how we do this problem. Fine. And okay. So now we will go with the next problem. Right? I'm just checking time whether, because I don't want to exceed some limit in the GB of the recording, so that in that case I'll not be able to copy the videos. So that's why I keep checking my time. It's around 27 minutes of recording. I'll continue if we have some more time. So fourth problem is, using Euclid's division lemma, show that a square of a positive integer is of the form 3m or 3m plus 1. So what we have to show? To show is, or to prove is, square of a positive integer, square of any positive integer is of the form 3m or 3m plus 1. 3m or 3m plus 1. So what it says is, you take any positive integer and then you square it. Any integer. Suppose if I write 5 square is what? 25. Any integer. This 25 I can write it as either 3 into something plus 1 or 3 into something. This I can write as 3 into 8 plus 1. Right? So this is like 3 into m plus 1 in this form. Any square number you take. Any number. Suppose if I take 64. 64 can be written as 3 into how much? 65, 62. 63 will go 3 into 21 plus 1. So this is also in the form 3m plus 1. Any square number. 64 is what? 8 square. Right? Any square number. Suppose if I take 9 square, which is 81. 81 can be written as 3 into 27, which is in the form of 3 into m or 3m, whatever. So any square number you take, you can write only in either 3m plus 1 or 3m form. 3m or 3m plus 1, and that is what we need to prove here. Now how do we prove this? Again, so we'll take, solution is, we'll take let a be any positive integer. A be any positive integer. That's how we start. And then we will take b as, let b equal to whatever form we need to prove, 3m or 3m plus 1, that 3 will become the b, right? Mostly this 3 will become the b, right? Now we should apply Euclid's division lemma. So by Euclid's division lemma, if you apply that, what do we get? A equal to bq plus r and 0 less than or equal to r less than b. So which means A is A, there is no specific value, but b is 3q plus r, comma 0 less than or equal to r less than b, which means 0 less than or equal to r less than, what is b? B is 3. Now again A becomes 3q plus r, comma when r is between 0 to 3, which means r can take the value 0, 1 and 2. It starts from 0 and goes till 2, not 3. I cannot put 3 because 3 is not less than 3. So 0, 1, 2. These are the 3 values. Now we need to have 3 cases for these. So we will have first case 1. Case 1 is when r equal to 0. When r equal to 0, then what happens? When r equal to 0, my a equal to bq plus r. My a will become, sorry, I will take this 3q. I have to take this 3q plus r, right? My a equal to 3q plus 0. So a equal to 3q. 3q plus 0 is 3q. Now we should find what? Square of any positive integer. Which means we should square this number. We should square this a. So a square will be what? We have to prove a square is in this form. Not a is in this form. We should prove square of any positive integer. Square means we should prove a square. A square is in this form of 3m or 3m plus 1, which means we should square a. So if I square a, it will become 3q the whole square. So I'll get a square will be 3q the whole square is 9q square, right? 9q square. So my a square becomes, I can write this as 3 into 3q square. Then it becomes a square is equal to 3m, where m is equal to 3q square. I am calling this whole thing as m. So 9 can be written as 3 into something. 9q square, how can I write 9q square as 3 into something? If I take 3 common, then this 9 can be written as 3 into 3. So if you multiply, you will get back this. Now a is in the form of 3m. So we have proved 1. Right? Second is we need to take the next case when r equal to, so case 2. Case 2 is r equal to 1. So my a becomes what? A is 3q plus r. So a becomes 3q plus 1. Now we should do the square of that a. So a square will become 3q plus 1 the whole square. So a square equal to, because we need to put the square of the number. So we should square this. So don't stop here. Don't stop there. We need to square it. So if we square this, then what do we get? So this will become, we have to apply a plus b the whole square. That is a square plus 2 into a into b, where a is 3q, b is 1, plus b square. So a square becomes 9q square plus 2 3s are 6q plus 1. Now there is a plus 1 is coming. Then it may take this form. 3m1 plus 1 from, because 3 is not common everywhere. We have to first check whether I can take 3 common from everywhere. I cannot take 3 common because this has 3, this is divisible by 3, 6 is divisible by 3, but 1 is not divisible by 3. So it may not take this form, but we have to check whether it is in this form. So which means here, at least with these two, can I take 3 common? Right? Yes, I can take 3 common, because if I take 3 common, I'll get this as 3q square plus 2q plus 1. This one I'm writing as it is. From these two I'm taking 3 common. Then this will become 3 into m plus 1, which is a square, where my m is equal to 3q square plus 2q. So what I have got? I've got my a square is in the form of 3 into this whole thing. I'm calling it as m, 3m plus 1, where m is this whole thing. So now a takes the form of 3m plus 1. Now the third case. Third case is when r equal to, when case 3. Case 3 is when r equal to 2. When r equal to 2, what is a? So a is 3q plus r. So a equal to 3q plus 2. I am substituting r as 2. Then I should find a square. That becomes 2. We are squaring both sides because we need the square of the number. Square of the positive number. Not the positive number is not in this form. You have to say square of the positive number. So once you find a, you have to square this. Then apply a plus b the whole square formula. A square plus 2 into a into b plus b square. So this becomes 9q square. 3q the whole square is 9q square. 2 2s are 4. 4 3s are 12. Q plus 4. That is my a square. Now we should check whether do we have 3 common in all the 3. Do you have 3 here, here, here? No. 3 is not here. 9 is divisible by 3, 12 is divisible by 3, but 4 is not divisible by 3. Then we should break 4 as 3 plus 1. So my a square will become 9q square plus 12q plus 4. I can write it as 3 plus 1. When I cannot take 3 common, you should break that into 3 plus 1 so that at least I can get it in this form of 3m plus 1. So now a square equal to, now from these 3 I can take now 3 common. Don't write 4 as 2 plus 2 or anything. You should write it as 3 plus 1 so that I get a 3. So that I can at least take 3 from these 3. So plus 1 is there which will take this form. So this whole thing I will get 3q square plus 4q plus 1. Then this is plus 1. From these 3 if I take 3 common, then this will become 3q square, this will become 4q, this 3 will become 1, this plus 1 is separate. So my a square becomes 3 into this whole thing I can call it as some m. Right? So where my m is 3q square plus 4q plus 1. So now what happens? My a square is in the form of 3m plus 1. So in all the 3 cases, my a square either takes the form 3m or 3m plus 1. So that is the proof for this. You have to check for all the 3 cases. So in all the 3 cases, we got this result. Either you see it as 3m or 3m plus 1 only. So therefore, we can say, therefore, any square of any positive integer is of the form 3m or 3m plus 1 for some integer, so for some integer m. For some integer m, the square of any positive integer is of the form 3m or 3m plus 1. So we have proved this. Clear? So we'll stop here. We'll continue on the next video. Please watch my next video for the continuation of this. Thank you for watching.